How many marks do I make?
5.
So totally how many marks am I going to make?
60.
5 times 12, right? I'm just going to multiply. And then each corner has how many marks around it?
3.
So I have 60 divided by 3. So this is yet another method for, so vertices is also, I'll put this, can people see if I write it down here, or is that a little tough?
We did.
V is also equal to the number of faces times the number of vertices on each face divided by the number of faces each vertex touches. So we can use this table to generate many, many different kinds of formulas. Sorry, my chalkboard writing is bad. I usually write with a chalkboard, not with a marker. So vertices on each face times f. This is kind of the number of marks I draw. And then I have to divide because near each corner, this is the number of marks I've drawn near each corner. This is, so for this one for this one, 20 was 12 times 5 divided by 3. The number of faces, number of vertices on each face, divided by the number of faces. Now, I know many of you are teachers in 1 and 2, and multiplication may not be there yet for the kids. One sec, I just want to finish with one thing. And Dave is going to give us some great tips on what we can do with grades 1 and 2, because of course multiplication is not something that they've seen yet. But the idea of counting in different ways, counting the number of marks they've made on each thing, that is something that in my experience has worked. Like the idea of just counting and, oh, how many marks have I made, so they can count. The other thing that they love, and this is usually, I start the session with this, I say at the end of this session you're going to discover a formula that it took mathematicians 2,000 years to discover. So now what's that formula? There is a way of taking this data, the data that we have here with edges, vertices, and faces, and you can put I won't tell you exactly how yet, maybe you can tell me in just a second. You can put a plus sign somewhere and a minus sign somewhere, so that the answer you get in all of these rows is the same. If you go across the rows and you put a plus sign one of these places and a minus sign in one of these places, you get the same answer. Can anybody tell me where I should put the plus and where I should put the minus? The answer is going to be the same across all the rows. So no more multiplying, no more dividing. I just look at these numbers going across, and when I see this, I put either a plus or a minus, and when I see this, I put either a plus or a minus. So put a plus here.
No, minus.
No, forget all the divide by 2, just look at these numbers now. So let's forget all the other formulas.
Okay, so 4 plus 6 minus 4.
But would that give you the same answer as we go down the roads?
No.
What's the answer we're looking for?
Well, that's part of the question.
I see what you're saying.
I want the same answer. I want to put a plus and a minus so I get the same answer across all the rows.
6 minus 2.
The answer is, so Dwayne says the answer for all that we should be getting is 2.
Minus plus.
Huh. So if you don't like negative numbers, which is fine, you can do the plus first, and then you can do the adding up here. So I'll just put a plus here, this here.
And I think it's because of the folding. Then.
And so you get 2. This formula is called Euler's formula.
Because of the points.
I would not, when I first saw this name, I would not have said it Euler. I called it Euler.
I was going to say.
Yeah, it's Swiss. I don't know. They're weird.
Just like me.
Yeah.
Exactly, perfect.
Yeah, he's from Dave's clan. You should be very proud of him, actually. represent the fact that all of these give you the same answer too. So the last thing I'm gonna say, what's one other thing these things have in common? They don't have any holes. And this too, and we can talk, if you want to come and talk to me about this, we can talk about how this too represents the fact that none of these have holes. For right now though, I want to turn it over to Dave, who's going to say a little bit about what are some other things you can do, with, especially with the younger kids.
Math should be beautiful. Just seeing beautiful things and then seeing questions about it and methods of making beauty is a wonderful thing. Somewhere here oh yeah. So, a number of you made this. There are various ways to make various things that look like this, that come from this. In fact, this thing is related to a couple of these things. And I'm going to tell you a way to do this that's suitable for grades K1 and 2. I don't know about you, but my 5 and 6 year-old, my kids when they were 5 and 6 would not have done this. And this would have ended up as a crumpled ball. This would not have happened in my primary school kid ages. But there's a way to do it where we'll do sidewalk chalk and big cardboard and balloons that I'm going to talk about. But does anybody see how this is related to one of these guys? So which one is it related to? In fact, it's related to all of them, which is a really cool thing. But which one? Brenda, hold it up.
Triangle.
In fact, I don't know if you can stop. If you take this, ooh, I don't know who's attacking here, but I'm attacking somebody's ball. Stick that in there. I can seal it up. You'll have to look at this, but the dodecahedron has some 5s in it, it has some 3s in it, and it has some 2s in it.
So 5s, some 3s, and some 2s.
Right? And this crazy thing has some 5s and some 3s and some 2s in it. And they can kind of line up. In fact, the dodecahedron is kind of hard to make. Maybe the first thing you would make is a big cardboard pentagon. And in fact, there's a nice way to do this. Maybe we can post this on our website. And make another one, and you can put them together. In fact, better than making it out of cardboard is to make it out of easel board paper or butcher paper. Go to the grocery store and ask the butcher if you can have a couple big sheets of paper, and you're going to make some triangles, and you're going to make some pentagons and some squares, and then you take 2 and you put it together kind of like a pillow, and you have them draw a figure on it. They can draw a curve, a little swirly kachina thing,
Smiley face.
but have it cross the edges. So make it go over here like this and around. Then you can open it up. And then you can either cut out holes with stencils in it and put it out on the sidewalk and draw with the sidewalk chalk on the sidewalk, or you can put another piece of butcher paper over it, trace it, lift it up, move it around, and trace it. If you do it with a triangle, like there are some triangles, like equilateral triangles, you can tolerate the names. Least important thing here. As long as we can agree on what we're talking about, you can make up your own Navajo names. But we can recover. And in fact, if ever, have you done these paper dolls before? Has anybody seen the paper dolls where you fold up a bunch of paper, take a pair of scissors and cut around it and go, you have this whole thing of paper dolls? You might not remember how to do that, but in this day and age, you pick up your phone and you go paper doll change, and you get videos and instructions, and then you can start making it. We can make mathematical paper doll chains, which go in 2 directions, or triangle chains like this. When you make 2 triangles like this, and you draw, fold it up like this. So you make a triangle pillow.
just not
See,
take
it's
one
like,
triangle, slap
and then
another
you
triangle
just
on
start
top.
drawing pretty art on it. I don't have, oh, I do have another color maybe. You know. And you let them draw something pretty on it, you open it up and you keep going. You're gonna have trouble filling the plane up with this. This will fit into a dodecahedron, and when it fits into the dodecahedron, you'll get some, that's how this thing was made. When they got these swirls to put together, they started just drawing a swirl. In fact, you could fold this even further so that you would just see 1/5 of it, and then unfold it. And in fact, Vi Hart, how many people have seen Vi Hart? Oh my God.
Let me write
We
this.
are going to put a link on the website, and you should watch. So homework, we do not often give homework. All of you will have homework to watch a Vi Hart video. She has so many very cool math activities that are accessible for everyone. In fact, it would not be bad to spend 10 minutes a day. I usually hate the idea of making videos and movies in a classroom, but if you once a week played a 10-minute Vi Hart video to your class, you would discover your kids would be doing math during recess and telling their brothers and sisters about it. I promise you they would do that. They will really get engaged. In particular, one of the ones she has on there that works wonderfully for the grades K and 1 and 2, she has a way where you buy a bunch of the round balloons, and you take a balloon and you fold it up into a triangular packet. You take a pair of scissors and you cut some shape out of it. You open the balloon up and it'll look like a floppy one of these things. You maybe do it in a red balloon. Then you take a yellow balloon and you slide the yellow balloon into the red balloon. You blow it up, you tie a knot in it, and you have this yellow thing with this red thing that's exactly these patterns that are exactly the platonic groups. And balloons, this is a party for your kindergarten, first grade, second grades. They're going to be bopping them back and forth, cutting balloons with scissors.
Dave, if your laptop's up and connected, we could pop up one of those. We could pop up that video if you could find it. I mean, that might be.
Yes, in
a
fact,
fun finish to
I'm
the
going to,
lesson.
so we'll get the other group together and I'll get the website and I will show stuff in here where our website is and where these materials are. In fact, I will take just a minute and get the Vi Hart video here.
Yeah, my only concern with bringing the other group in here is where are they going to sit?
Well, this is the only monitor they have, and there's only like 4 other people that stay behind, and so they'll stand in the back, or, you know, who will suffer for the video. Let me point out, when I say that this thing was built in this model, one of the things we did is we started gluing on from all the points that had 5, we started connecting them with pink to the other points that had 5. In fact, giving you the triangles in one of the friends. Yes. And then we connected, each triangle has a center, which we connect to the 5, and we get 5 things coming out. Then the centers of the triangles we connect with blue, and we get the blue dodecahedron. So we've got the blue dodecahedron and the pink icosahedron friend with the green, you get to think what it is, which is how this thing is built. You think your students would enjoy seeing this?
Yes.
If the 3D one is too hard, sidewalk chalk, I promise you kids can do sidewalk chalk, and if you make the rules, the hardest part is going to be the discipline of, okay, we're not drawing pictures of kitties and doggies now. We might draw one kitty, but then we're going to unroll the kitty so that we get this whole kitty mosaic. By the way, this might be a good coffee break,
Yes.
and I will get the computer set up. There's coffee in the hall. Breakfast might not be here yet. The other group is wrapping, and I'll put a Vi Hart video or 2 in the webpage.
And please, you know, if you don't have my email address, which I wrote up there, you can come get it from me. Please contact me if you are planning on doing one of these activities, and if you have questions or comments, or if you need, we're gonna store some of these right here at CDTE. So if you need some of these, we can definitely contribute, and we can send more of those down to you as well. So we have lots of these polyhedral sheets, and I have lots more activities to build on. This is just a taster for you guys.